Rationalization of sets. What is it? If we have a set in the denominator, we don't want to see it. Don't want to see the radical sign in the denominator after simplification of sets. So whenever I finish simplifying sets and there is a root in the denominator, it means your work is not yet complete. So what we do is we multiply both the numerator, which is a, and the denominator by the set in the denominator. So that gives us root of a times root b over root of b times root b. So this gives us root ab over b. So no problem over here. There's no root in the denominator. What if it is of this nature? Still, we don't want the root like this, even though this is a whole number or this is a rational number. We don't want to see this set in the denominator. So what do? We look for the conjugate of 1 minus root b, which is 1 plus root b. Use it to multiply both the numerator and the denominator. So you do that, we obtain something like this. So 1 minus root b times 1 plus root b. Then you do the same thing to the numerator. Then now you simplify to obtain root of a into bracket 1 plus root b all over 1 minus b into 1 plus b. So you can see that there's no radical sign in the denominator. Now, what if it is of this nature? So we don't want to see it like this. We don't want to see the radical sign in the denominator. So you have to multiply both the numerator and the denominator by the conjugate of root of a minus root of b. So that will give us something like this. And when you simplify, you obtain something like this. Now let's look at some work example from WASSCE. So we are rationalizing 5 root 7 minus 7 root 5 over root 7 minus root 5. So this is of that form, root a minus root b. So we just multiply by the conjugate of root 7 minus root 5, and that is root 7 plus root 5. So we have something like this, root 7 plus root 5. So both the numerator and the denominator. Now we multiply out. So this is multiplying out all of this. So 5 root 7 minus 7 root 5, then multiplying root 7 plus root 5 all over root 7 minus root 5 multiplying root 7 plus root 5. So we expand this to obtain 5 root 7 squared, and we have plus 5 root 7 plus 5 root 5 plus 5 root 5 times root 7. So then we have plus 7 root 5 this is supposed to be minus, so minus 7 root 5 root 7, then we have minus 7 times root 5 all squared. So this all over, this is all over difference of two squares, which is root of 7 all squared minus root of 5 all squared. So this goes further to 5 times 7 plus now 5 root 7, 5 root 5 root 7 minus 7 root 5 root 7 will give us negative 2 root 7 root 5, then minus 7 times 5. So all over 7 minus 5. Now we simplify further. So this will give us 35. I think this and this are the same, so they will cancel out. So let's do it that way. Now this will cancel this, so we are left with negative 2 root 35 all over 2, and this will give us negative root 35. Now we have this one, we are simplifying it. We have several ways we can do it, but I want to do it using rationalization. So we have 1 over 1 plus root 5 minus 1 over 1 minus root 5. So we rationalize each of them. So we are going to obtain something like 1 over 1 plus root 5, 1 plus root 5. Then we multiply both the numerator and the denominator by the conjugate, which is 1 minus root 5. Then minus 1 over 1 minus root 5. Then we multiply the numerator by 1 plus root 5 over 1 plus root 5. So this simplifies to 1 minus root 5 all over 1 squared minus root 5 squared. So we have this one to minus 1 plus root 5, 1 plus root 5 all over 1 squared minus root 5 squared. So we simplify further to obtain 1 minus root 5 all over 1 minus 5 minus 1 plus root 5 all over 1 minus 5. So we obtain 1 minus root 5 all over negative 4 over all minus 1 plus root 5 all over negative 4. So negative 4, negative 4. So this will be equal to 1 minus root 5 minus 1 minus root 5 again all over negative 4. So this simplifies to, I think, negative 2 root 2, negative 2 root 5 all over negative 4. And this will give us 1 over 2 root 5. So we are simplifying 2 root 3 minus 5 root 2 over root 3. So let's split the numerator first. So we are going to obtain 2 root 3 over root 3 minus 5 root 2 over root 3. So this will give us root 3 will cancel. So we obtain 2 over here. Then minus, we will rationalize this one. So 5 root 2 over root 3 times root 3 over root 3. So this will give us 2 minus 5 root 6. Then root 3 times root 3 will give us 3. So the correct answer is C. Now we have this one. We are rationalizing this. 7 minus root 3 over 13 minus root 3. So we multiply both the numerator and the denominator by 13 plus root 3. So this is going to give us 7 times 13 plus root 3 minus root of 3 times 13 plus root 3 all over 13 squared minus root 3 squared. So we expand to obtain 91 by 7 root 3 minus 13 root 3, then minus root 3 squared, all over 169 minus 3. So this gives us 88 minus 6 root 3 minus 6 root 3 all over 166. So dividing through by 2, we obtain 44 minus 3 root 3 minus 3 root 3 all over 83. It's 83 all over 83. So the correct answer is C. Now, this is not the end. We have more of these videos. If you want to practice enough, you want to learn more of the topics in mathematics and be able to solve these exams from WAEC, JAMB, NECO, and WASSCE, just visit www.wassce.com. So over there you get more of these tutorials for free. So just type exactly what you are seeing on the screen, then it will take you straight to that website.